Hey guys, welcome to another video, and today we're going to be tackling a problem from the Mind Your Decisions channel. You should subscribe to him. He makes great videos and interesting problems. This problem comes from this video URL right here. Okay, so check it out. Alright, so the problem is this. You have a square, 1 by 1 square, and then you have a line that's tangent to the circle that hits the corner of the square. Okay, and you want to find the length of the line. Okay, and it's like inside the square. Okay, and the circle that it's tangent to is it's actually a semicircle that's inscribed with the square. So the radius is 1/2 basically. Okay, it won't go outside of the square. Okay, so let's go ahead and solve this. Okay, guys, so this is a very interesting problem. In Paresh Talwalkar's video, he went ahead and used some nice geometry, and he proved it really elegantly. But if you didn't know those geometrical things beforehand, it'd be really sort of hard. I personally find, proofs in geometry really elegant, but really hard to accomplish. I don't know. One problem-solving strategy that I've found that works really well is imposing a coordinate system, okay? So we can impose a coordinate system by making this point on the bottom middle of the square 0, 0, okay? And then this line will be, since it's a 1 by 1 by 1 square, this right here will be x is equal to 1/2. The line x is equal to 1/2, and this point right here will be negative 1/2, comma 1, okay? Now we know this line right here has to be of the form y equals mx plus b, okay? And we know that this circle has to be the form x squared plus y squared equals r squared. And the radius here is actually 1/2. So it's 1/2 squared, which is 1/4. Okay, let's talk about this line. What do we know about the line? Okay, we know y is equal to mx plus b. We know it goes to a point negative 1/2, 1. That means this must be true at y is equal to 1, x is equal to negative 1/2. So 1 is equal to m times negative 1/2 plus b. Okay. We can go ahead and solve for b here. So b is equal to 1 minus negative 1/2. So it's turned into a plus 1/2 m. Okay. And just remember this for later. Okay. So next up on the menu is to look at this circle. Let's go ahead and think about what this point right here means. We looked at this point. What does this point mean? Well, it's tangent to the circle. That means this line only crosses the circle at one point. Okay, what does that mean? That means that the relationship y equals mx plus 1/2 m plus 1, because remember b is 1/2 m plus 1, and x squared plus y squared is equal to 1/4. There's only one solution where both of these relationships are true. One solution for x and y. Okay, so let's write that down. So we want y equal to mx plus 1/2 m plus 1, and we want x squared plus y squared equals 1/4. Okay. Okay, what can we do? Well, we already know what y is, so we can plug in that. So what do we get? We get x squared plus mx plus 1/2 m plus 1 squared. Because remember y, okay? And then is equal to 1/4. And that has one solution. Okay, let's talk about that. Okay, so we had this as y squared. Okay, let's go ahead and do that. So this is it factored out. Alright, all expanded, and this is going to be a really cool part. Let's try and find the common terms. Okay, is there any m squared x squared in the rest of it? I don't think so. Is there any 1/2 m squared x? Yes, right here and right here. These guys combine to be what? 1 mx squared. So just m squared x. Sorry. And then we have our m squared x squared right here. Okay, What else can we find? Is there any more mx? Yes, right here and right here. So plus 2mx. Okay, what else can we find? Is there any 1/4 m squareds? Or any m squared terms? No. Okay. Well, okay. There's a 1/2 m and 1/2 m right here. So that turns into a plus m. Okay. And then plus our 1/4 m squared and then plus our 1. Okay. And I don't know. Please leave down in the comments if this video is really choppy. I'm trying out a new style where I just take clips instead of just doing it all by hand to like shorten the length. Okay, so we figured out what y squared was. We expanded that out. I went ahead and skipped a couple steps. You can do the algebra yourself, but I went ahead and factored out an x squared, an x, and nothing. Or I factored out an x squared and an x from this to get this. Okay, this equation, and I moved the 1/4 to the other side. Okay, notice that this equation, or right here, is of the form ax squared plus bx plus c is equal to 0. A is equal to m squared plus 1, b is equal to m squared plus 2m, and c is equal to 1/4 m squared plus m plus 3/4. Okay, and notice that a is not equal to 0. Okay. Unless the only way a can be 0 is if m squared is equal to -1, and that doesn't even make any sense. We're in the real world. Okay, so we have ax squared plus bx plus c. Watch my quadratic formula video, but if you want to see why this is true. But then we know the solutions to x is x is equal to -b plus or minus square root b squared plus 4ac, or is it minus 4ac?
Minus 4ac.
Minus 4ac all over 2a. Okay. And notice it's a plus and a minus. What does that mean? That basically means that there are two solutions. One is the positive version, and one is the conjugate, the negative version. Okay. But remember, what is this x? What is this solution? Well, it's the solution for the intersection between this curve and this curve, or whenever the line crosses a circle. And remember, it's tangent. Tangent basically means it only crosses at one point. So, the only problematic thing is this right here. So, let's see. We want there to be one solution. What is that? Okay. What if you have square root of b squared minus 4ac equal to 0, then plus 0 is equal to -0. It doesn't matter. So we could square both sides and we get b squared is equal to 4ac. B squared minus 4ac equals 0 squared, or just 0. Okay, let's work with this. Alright, we're on the home stretch, boys. Okay, so we have b squared minus 4ac equals 0. Alright, we can substitute in our b, our a and our c. Okay, and let's go ahead and put the 4 in our c term. And then let's go ahead and use a binomial theorem to go ahead and expand the b squared term. Okay, so this b squared is m to the 4th power plus 4m cubed plus 4m squared. I actually messed up and I forgot that term in the beginning, so I just added that here. Okay, and then putting the 4 in here, the 1/4 m squared turns into a normal m squared, the m turns into a 4m, and the 3/4 turns into a 3. Just to make it easier. And then we just expand this out, and we get this. Okay, and here's the very satisfying part. Should I use green or blue for this part? I'm gonna use blue. Okay. M to the 4th power minus m to the 4th power. 4m cubed minus 4m cubed. Okay. 3m squared plus m squared turns into a 4m squared, but it's a minus 4m squared plus 4m squared. Okay? And then all we're left with is a plus 4m plus 3 minus. Okay? Minus 4m minus 3. Of course, you can multiply both sides by -1 to get 4m equals 3. and then we get m is equal to 3/4, right, Jerry? Okay. Okay, slight error in the last clip. M is actually equal to -3/4. I sort of messed up there, but okay. So we have our line, y is equal to mx plus 1/2 m plus 1. If you plug in our -3/4 for m, simplify it down, you get y is equal to -3/4 x plus 5/8. If you remember back to the original problem, it was asking the distance from one corner of the square and then a line intersecting the other side. Okay, so here's the corner, -1/2, 1, and then here's the side and the point where it intersects that side. The point where it intersects that side is x equals -1/2 from the line, and then y is equal to y of 1/2 of the line right here. Okay, so what is y of 1/2? Let's think about this. So y of 1/2 is what? It's -3/4 times 1/2 plus 5/8, and then -3 times 1 is -3. 4 times 2 is 8 plus 5/8. 5 minus 3 is what? 2, and then 2/8 is 1/4. Okay, not bad. So we have our 2 points, and we want to find the distance. The length L is the distance between them. It's the length of the line. So we want to find the distance between the points -1/2, 1 and the point 1/2, 1/4. Like that. Okay. What's the distance formula? Well, we use the Pythagorean theorem. Square root of, let's see.
Move over.
Oh, sorry. Alright, home stretch, boys. So L is the distance between these 2 points. Just use Pythagorean theorem to figure out the distance formula, honestly. It's not that difficult. And, yeah, it's 5/4 or 1.25. Thank you for watching this video. It was a lot of fun to make this longer sort of video. Tell me in the comments if you like the sort of choppy, clipped videos. It's really, because before when I tried to make long videos, they ballooned out because I write so slowly. So I hope you enjoyed just this sort of style. Next week's video is probably going to be this word problem I created. And I'm going to try a different style of video. Okay, thanks for watching. Have a great day. Bye.